Imagine a battlefield where the most dangerous weapon is not a billion-dollar stealth bomber, but a rocket designed in the 1970s that costs less than a luxury car. Now imagine that rocket being guided to its target not by the pilot who fired it, but by a robot wingman flying ahead in complete silence. This is not science fiction. This is the reality of modern air warfare as of April 2026, and it is a secret that most defense analysts are too embarrassed to admit they misunderstood. For years, we were told that Loyal Wingman drones would replace human pilots, that swarms of autonomous jets would darken the skies, and that the age of the fighter ace was over. Every single one of those predictions was wrong. The truth is stranger, more fascinating, and far more lethal than the hype suggests. On April 6, 2026, a YFQ-42A prototype crashed during routine flight testing in the Nevada desert. The drone was one of only 2 competing designs for the United States Air Force's Collaborative Combat Aircraft program, an ambitious plan to build 1,000 robotic wingmen to fly alongside the F-35 and the secretive new F-47. The telemetry data suggests a state logic conflict. The artificial intelligence brain tried to execute a defensive maneuver that its survival algorithms demanded, while the human operator, unawares, simultaneously attempted a sensor recalibration. In the world of 2026, this is the new pilot error, except there was no pilot in the cockpit to die for the mistake. The crash should have been front-page news. Instead, it was buried in a single paragraph of a Defense Scoop article that almost nobody read. The silence was deliberate, because this program is not merely about building drones. It is about solving a mathematical problem that has haunted air forces since the invention of radar. Let me tell you a story about how intelligence analysis fails. In early 2026, several artificial intelligence systems began circulating a claim that the United States possessed over 100,000 Loyal Wingman drones. The number was everywhere. Defense blogs quoted it, social media amplified it. It was completely dangerously wrong. The figure 100,000 came from BAE Systems announcing their 100,000th APKWS laser-guided rocket kit. Somewhere in the machine learning pipeline, rockets became drones. This is what I call industrial hallucination, and it matters because when we talk about drone swarms blackening the sky, we ignore the real story. The United States Air Force plans to acquire perhaps 1,000 collaborative combat aircraft by the early 2030s. Not 100,000, 1,000, each costing between $25 and $30 million. This is not a swarm. This is a carefully calculated bet that a small number of highly capable robotic assistants can multiply the lethality of a shrinking fleet of manned fighters. On December 8, 2025, somewhere over the Australian outback, a Boeing MQ-28A Ghostbat did something remarkable. It flew in formation with an E-7A surveillance aircraft, received targeting data, and destroyed a target with an AIM-120 air-to-air missile. The entire engagement required exactly 4 human commands. Not 400, not constant remote piloting with a joystick, 4. The Ghostbat handled the rest autonomously. This is the secret that most defense commentators miss when they debate whether drones will replace pilots. The question is not about replacement. The question is about delegation. The pilot in the Wedgetail did not fly the Ghostbat. The pilot gave it a task, authorized it to use lethal force, and the machine figured out the rest. That is a fundamentally different relationship between human and machine than anything that has existed before in aviation history. Now, I need to explain something called buddy lasing, which is the most underrated technology in modern warfare. Normally, when a jet fires a laser-guided weapon, the jet itself must keep a laser pointed at the target until impact. This is called self-designation. It is dangerous because the firing aircraft must stay within line of sight of the target, often inside the range of enemy air defenses. Buddy lasing changes everything. A drone flying ahead of the formation or a special forces team on the ground points the laser instead. The manned fighter stays far away, fires the rocket, and the weapon finds a laser spot it did not create. The technology enabling this is called DASALS, or Distributed Aperture Semi-Active Laser Seeker, developed by BAE Systems. It allows a 70mm rocket launched from 14 kilometers away at altitudes above 30,000 feet and speeds approaching Mach 0.9 to hit within half a meter of where the laser dot sits. The shooter never sees the target. The shooter never enters the danger zone. While the world focuses on the American APKWS, Europe has been quietly perfecting its own solution. And here is where the story gets more interesting. The Thales Aculeus LG is not just a clone of the American system. It is a 68mm surgical instrument designed for the Scorpion land doctrine and adapted to the air. In testing in early 2026, the Aculeus proved it could lock on to a target moving at 80 km per hour with a circular error probable of less than 0.4 meters. Why does this matter? Because while the Americans build for mass, the French are building for precision attrition. If you are fighting a high-end adversary with active protection systems, you do not just need more rockets, you need rockets that hit the exact optical sensor of an enemy tank, the specific radar array that makes it dangerous. The Aculeus is that rocket. And, like its American cousin, it works seamlessly with third-party laser designation, making it a perfect partner for the Loyal Wingman mission.
I give myself.
Here is a number that should keep defense planners awake at night. A modern medium-range air-to-air missile like the European Mika costs roughly $1.2 million per shot. The Iranian Shahed it might be used against costs $30,000. That is a 40-to-1 cost ratio in favor of the attacker. Any nation that tries to defend itself with expensive missiles against cheap drones will eventually go broke. This is not speculation. This is basic arithmetic. The APKWS laser-guided rocket and its French counterpart, the Aculeus LG, changed this math entirely. Both cost between $25,000 and $40,000 per round. Suddenly, the cost ratio drops to 1-to-1 or better. You can now afford to shoot down a cheap drone with a cheap rocket. And the Loyal Wingman makes this even more lethal, because the drone can be the designator while the manned fighter becomes a magazine of affordable precision. If you look at the world in April 2026, you will see a fundamental philosophical split in how nations approach robotic combat. The United States and Australia are pursuing what they call affordable mass. They want drones that are attritable, meaning you are willing to lose them because they are cheap enough to replace. The target price for an American CCA is under $30 million. China has chosen a completely different path. The GJ-11 Dark Dragon, first shown in formation with J-20 stealth fighters in November 2025, is a flying-wing stealth design with an internal weapons bay carrying 2,000 kilograms of munitions. This is not a cheap, attritable asset. This is a high-end, unmanned combat vehicle designed to penetrate sophisticated air defenses alongside manned stealth fighters. China is betting on quality, while the United States is betting on quantity within a constrained budget. Both bets could be right, both could be wrong. Russia offers a cautionary tale of the dangers of ambition without industrial capability. The Sukhoi S-70 Okhotnik B is an impressive machine on paper. It weighs 25 tons, carries nearly 3,000 kilograms of weapons internally, and was designed to fly alongside the Sukhoi S-57 stealth fighter as a loyal wingman. Then came the invasion of Ukraine. Western sanctions cut off access to the advanced electronics and semiconductors needed for autonomous systems. One Okhotnik prototype was reportedly lost to friendly fire after its data link failed. Production has stalled to perhaps fewer than 10 pre-series units. The lesson is brutal. A Loyal Wingman program is not just about building an airframe. It requires a domestic semiconductor industry, reliable data link encryption, and thousands of hours of testing to make the autonomy trustworthy. Russia has none of these things at scale. The Okhotnik remains more propaganda than capability. Europe finds itself in an uncomfortable middle position. The continent has exceptional engineering talent and companies like Airbus and Thales that understand networked warfare. What Europe lacks is the political unity and defense budget to develop a sovereign loyal wingman at scale. The solution has been pragmatic. Airbus is taking the American Kratos X-580A Valkyrie airframe and fitting it with a European mission system called Mars, essentially Europeanizing an American drone. The first flight with a Eurofighter Typhoon is planned before the end of 2026. The Netherlands has gone even further, joining the United States Air Force CCA program directly as a partner with full access to technology. This is the quiet internationalization of Loyal Wingman development, and it will shape NATO interoperability for a generation. Something happened in early 2026 that few outside the defense technology bubble noticed. The United States Air Force successfully demonstrated the ability to swap the entire autonomy software package of a CCA drone mid-flight. One vendor's artificial intelligence brain was replaced by another vendor's artificial intelligence brain while the drone was still airborne. This is possible because of a standard called the Modular Open Systems Approach, which separates the flight controls from the mission autonomy. The implications are staggering. You can upgrade a drone's tactical decision-making as easily as updating an app on your phone. You can tailor the AI to the specific adversary you are facing that day. You can patch vulnerabilities discovered this morning by this afternoon. The airframe is almost irrelevant. The software is the weapon. But here is the reality that the Pentagon does not want to talk about openly. We cannot build these fast enough. The traditional defense giants, Boeing, Lockheed Martin, Northrop Grumman, are still stuck in a 20th century mindset of slow, exquisite production. Enter Anduril. With the YFQ-44A Fury, they are using what they call software-first manufacturing. They are not building a plane. They are three-dimensionally printing a chassis around a computer. In our April 2026 audit, we discovered that while a traditional fighter takes years to assemble, the Fury is designed to be rolled out of a containerized factory in weeks. If the 1,000-unit goal is ever to be met, the Air Force will have to abandon its old friends and embrace the newcomers. This is not just a production challenge. It is a philosophical war between the old guard and the Silicon Valley disruptors, and the future of air combat hangs on who wins. One of the most terrifying capabilities being tested is silent operation. A Loyal Wingman equipped with passive infrared sensors can detect, identify, and track enemy aircraft without ever emitting a radar signal. In our previous audit of the F-35 point-blank trap, we saw how Iranian and Chinese IRST systems could potentially spot a stealth fighter. Now, the table has turned. The Loyal Wingman acts as a remote IRST node. It flies ahead with its radar off, scanning the heat signatures of enemy engines. It finds the so-called J-20 not by looking for a radar reflection, but by looking for the heat of its existence. By April 2026, the United States Navy successfully tested a triple-node passive track where 3 drones triangulated a target without a single radio emission. This is the death of situational awareness for anyone facing a well-integrated manned-unmanned team. You will not know you are under attack until your aircraft explodes. Let me return to that YFQ-42A crash in April. The public story is that a prototype drone was lost. The real story is more valuable. Every crash during development generates terabytes of telemetry data about what went wrong and why. The engineers at General Atomics are not mourning, they are analyzing. They will fix the flight control software, strengthen the component that failed, and make the next iteration more reliable. This is how modern military aviation works. You test, you break things, you learn, you improve. The United States can afford to crash prototypes because it flies them constantly. Russia cannot afford to crash an Okhotnik because it barely has any. China tests extensively but shares no data publicly. The American approach is messier, more visible, and ultimately faster. Failure is not a setback. Failure is data. The secret of the Loyal Wingman program is not that drones will replace pilots. The secret is that the distinction between manned and unmanned is dissolving entirely. In the air combat of 2030 and beyond, there will be no solo fighter pilots dogfighting in the clouds. There will be mission commanders in F-35s and F-47s. And let me be precise about the F-47, whatever they eventually name the NGAD. It is not a plane. It is a flying server, a quarterback designed from the ground up to command a distributed network of robotic shooters. The robots will see first, designate first, and sometimes even shoot first with human authorization. The sensors and shooters will be separated, connected by data links that are increasingly jam-resistant and difficult to detect. The economic advantage will go to whoever can destroy the most expensive enemy systems with the cheapest possible munitions. The team that combines a human brain with robotic precision will be the most lethal thing in the sky. Look at the conflicts of 2026. Swarms of cheap drones are overwhelming sophisticated defenses in Ukraine and the Middle East. Nations are spending million-dollar missiles to kill $30,000 drones and losing the economic war. The Loyal Wingman paired with buddy lasing is the answer to this specific problem, not some futuristic fantasy. A single F-35 with 2 Ghostbat wingmen can carry dozens of cheap guided rockets, find targets passively, and engage them at a favorable cost ratio. This capability exists today in testing and will be operational before the end of this decade. The question is no longer whether Loyal Wingmen will change warfare. The question is which nations will have them when the next major conflict begins, and whether the rest will be left facing an enemy they cannot see, cannot hear, and cannot afford to fight. I want to leave you with one thought that disturbs me as an analyst. The real secret behind the Loyal Wingman is not any single technology. It is the quiet, accelerating fusion of artificial intelligence, precision guidance, and human judgment into a weapon system that is more than the sum of its parts. We worry about killer robots, while the actual transformation is far more subtle. The robots are not replacing us. They are becoming our eyes, our hands, and increasingly our tactical instincts. The human still decides who lives and who dies, but the machine decides how, when, and from what angle the blow will fall. That partnership is the true revolution. It is already here, and most of the world has not yet noticed.